Hey guys, this is Elliot here, and this is my little tutorial on something that I sort of taught in class, actually introduced through another video tutorial and a worksheet, which is on how the eye sees an image in a plane mirror. And sorry, I'm a little sick right now, so I'm going to do my best to get through this for you. These are the ray diagram answers, so you'll have a look at the images for which I provided a worksheet for. There's two of them, and I'll see if I can put that on my website as well for you guys to download if you're watching this and you want another copy of it, or if you're at another school and you find this helpful. The answers are going to be displayed as soon as I switch pages here. So I'm not going to be able to walk through this part at a time. I'll show you what I mean in a second. So it sort of gives it away all in one go, but I will explain as best I can what I've done. Okay, so if you're in my class, you need to have that worksheet with the two diagrams of the plane mirror, the eye, and the object. So I'll show you that. All right, so here we go. So this is the first diagram that you would have, where this is the plane mirror. All right, these angular dashes represent the back of the mirror. So this is the face. This is the face of the mirror right there. And what you had really in the worksheet was just the eye over here. This is my eye, the best eye I could draw at the time. And the object in this case is just a dot. And you were to figure out how the eye views the object. So the image wasn't on the worksheet, and neither were these blue lines. And the idea is, okay, that when there's an object, let's say you're standing there looking at yourself in a plane mirror, right? There are four major characteristics, SALT characteristics: size, attitude, location, and type of image that you would see. So you are the object looking at yourself in a mirror, let's say. Forget about the eye for the moment. And the image will have those four characteristics. What is the size of the image? What is the attitude? What is the location? And what is the type? Now, this is just a dot, so it's very difficult to see some of those characteristics. The size should be the same, and I'm sorry about the fact that this image is drawn a little bit larger than the object. But I mean, if you're standing here looking at yourself in the mirror, this is you, all right? The image is going to be the same size. So that's the first SALT, S-A-L-T, SALT characteristic of images viewed in a plane mirror. It's important that we designate that we're talking about plane mirrors and they're not curved mirrors, which is the next thing that you'll be looking at. So the size of the image is the same as the size of the original object. They don't change. The attitude of the image refers to whether or not it's sort of right side up or upside down or inverted with respect to the object. So if you're looking at yourself in a mirror in the morning, you go to brush your teeth or comb your hair or something like that, right? You're right side up, and so is your image. You know, you're not right side up and then your image is upside down. You can't really tell that with this dot, but that would be the case. The location refers to where is the image with respect to the mirror. Now, the location of an image in a plane mirror is behind, all right? You can see these dotted lines, and I'm going to explain all these in a minute. The location of the image is behind the mirror. The object is in front, so you're standing there looking at yourself. Your image is behind the mirror, or so it would seem, all right? Now, that's not, again, always the case when you deal with some curved mirrors. Depending on the position of the object, the image could be in front of the mirror. And that brings us to the last parameter or characteristic, the type. The type of image, when the object is being viewed in a plane mirror, the image is a virtual image. It's not really there. I mean, think of this. This mirror is a solid object, solid thing, I shouldn't say, because I'm going to use the word object over here. This is the object. This mirror is a solid thing. How could the light rays be behind the mirror? It's not possible. This is just the way that light works, though, in optics, it's an illusion. The image is considered to be behind the mirror. It is behind the mirror, and this is not a real image. This is called a virtual image, and I know that's one of the weirdest concepts. What do you mean it's not a real image? I can see it in the mirror. How can it not be real? Was it a ghost or something? But you will see that in curved mirrors, you can have an image on this side of the mirror, and it's a real image. You're going to have to wait, I think, until we do curved mirrors for that to really make sense. For now, learn the four characteristics, the salt characteristics of the image as seen in a plane mirror. And the image is of type virtual. It is a virtual image because it's behind the mirror. Now, the other thing, I guess I'll start with these lines so it'll start making sense. So what you had again was the object, the eye, and the mirror. I'm going to erase that in a second, okay? But you had those three things and none of these lines. So what you do is you start by using your ruler and a nice sharp pencil, and you draw a line exactly perpendicular to the mirror. All right, it has to be perpendicular, not on an angle, perpendicular to the mirror, and you hit the mirror. All right, now you measure this line, draw it in solid, and you measure this line. And let's say it was 2 centimeters. You then draw a dotted or dashed line because it's not a real line. Okay, it's behind the mirror, it's not really there. The exact same distance, and then you draw your image dot. Now, you're not going to get it the exact same size, but keep in mind that in the salt characteristics, it should be. This is saying that the image produced is, in terms of its location, behind the mirror, and the exact same distance behind the mirror as the object is in front of the mirror. All right, so if you come in close to a plane mirror in the morning when you're brushing your teeth again, you know, your image comes in close the same amount. As you start to move away, your image starts to move away, and it's always the same amount. So solid lines in front of the mirror, dotted lines behind. So this is the first thing you do. You measure that. The second thing you do is you measure that, and you use dotted lines. Okay, now we want to know how the eye sees the image. Okay, keep in mind that light is coming from this object. All right, now we're not using this line as a real ray. You're going to notice these arrows. These represent the direction that light is traveling. There's no arrow on this one. This line is just meant to get the position of the image with respect to the object. If this was a candle or a flashlight and you turned it on facing the mirror, yes, you would have light coming straight and hitting and bouncing back as well, by the way. All right. And you could draw the flashlight on the back side of the mirror. All right. And that would be light streaming out of it. And light would go off in all different directions, not only to the mirror, but, you know, in every direction. You know, if this was a luminous source. If it's a non-luminous source, let's assume this is just a dot, then light is bouncing off it. I mean, ambient light in the room could be coming in here, hitting it, and it's bouncing off this way, and it's bouncing off that way. And that's where these arrows are coming into play. So this doesn't have to be a luminous object releasing its own light. Whatever you can see, if you turn on the bathroom light and your dog is sitting there and you see its reflection in the mirror, your dog is not glowing. Let's hope. All right, unless it's Superman's dog. It's just light is bouncing off it in all different directions. And we are only considering a couple of the rays, because otherwise this would be incredibly complicated. So you draw this line, solid line, and measure it. Dotted line, draw your image. Now, we then draw a couple of rays back to the eye. And typically what they do is they draw the ray going into the top of the eye and into the bottom of the eye. Of course, there would be rays going all around here, and some of them wouldn't even be seen by your eye unless you move your eye over there and you go, hey, I can still see the image. That's because there's more light rays. Okay? So what we do is we go roughly from the middle of the image, draw a straight line right to the top of the eye. But behind the mirror, we draw the line as dotted. And in front of the mirror, we draw the line as solid. Now, this is important, okay? When you do this on your tests and your final exam, you have to do it this way. You must dot or dash these lines, and these must be solid. So here's the top one, and here's the bottom one. Straight lines going back into the eye. Now, these are not perpendicular to the mirror as these ones were for figuring out the location, right? These are just going to the eye, but they're straight lines right through the mirror. Hits the mirror here, straight back. Now, these lines are actually used to figure out the reflections from the mirror into the eye. So we draw these first. So we went 1, 2, 3, 4. All right, and you don't have to measure this and then measure it. You just actually put your ruler down, you draw it, bang, hits the mirror, straight into the top of the eye. And there'll be a little bit of inaccuracies, I realize. Like, look, down here, I'm not exactly on the same spot on the bottom as I was on the top. That doesn't matter. Okay, 3, 4, 5, 6, let's say. But because these rays don't come out of the eye, you don't shoot laser beams or light out of your eye unless you're Iron Man or something. These are reflected rays into your eye, and so we put an arrow showing the direction of light, bouncing off the mirror into the top of the eye, bouncing off the mirror into the bottom of the eye. All right. Once we have those lines drawn, we then take one of them, let's say the top ray, and right where it hit the mirror, okay, we draw it back to the object. Now you're going to say, draw it back to the object, but the arrow's pointing this way. I know it's confusing, but you know, remember we had this one and then this one and then this one and then this one, this one and this one, and step 7. I mean, other than drawing the arrows, you could call that 7 and that step 8. Fine. All right. Then you draw this line and you go back to the object. But remember, light is coming from the object, and if it's easier to think of it as a luminous source, like, you know, your glowing dog or your flashlight or a candle or something, then think of it that way. Light is coming out of this, bouncing off the mirror into your eye. So the arrowhead goes this way. So be very careful about that. All right, it just should make sense. Light comes out of the object, hits the mirror, goes into your eye. You use this point in order to draw that. Now, I'm going to delete this again. You're going to notice that I drew some dotted red lines, if you can even see those. These represent the normal lines. You didn't necessarily have to draw those, but I put them on because a normal line is an imaginary line that is perpendicular to the surface of the plane mirror, or probably any mirror actually. And remember, the angle of incidence, which would be this angle here, right, as the light comes in, makes an angle between the normal line and the ray. The angle of incidence and the angle of reflection are the same. And so I just drew those lines there to kind of remind people of that and remind you of that. All right, so we've drawn this ray using the top line back to the object. And then from this point in the lower ray, dotted behind, solid in front, we've drawn that back to the object. And we put our arrowhead showing light is actually coming this way, hitting the mirror and going back. All right. So this is how the eye sees an image in a plane mirror. All right. The object is here. The image is the same distance behind. It's upright. It's same distance, but it's behind the mirror. It's a virtual image. And then the rays, of course, bounce off the mirror back to the eye. Now, this example has the plane mirror standing vertical, okay, or erect. Now, the next one, in the next example, I've just tilted the mirror a little bit. So let's have a look at that, just to try to make sure that you can get the same concepts. And of course, when you do this, you have to make sure that you label the object, label the image, label the eye. All right, so now I've taken the plane mirror and I've just put it on a bit of an angle. All right, you still started out on this worksheet with the object, the eye, and the mirror. All right, so do the same steps. Oops. Come on. There we go. You don't want... Oh, maybe I did it in PowerPoint. No, I didn't. Hang on a second here. Yeah, of course, in PowerPoint you can draw, right? But I'm using, here, I'll show you. I'm using Epic Pen, which is a great little download. There's a new version of this, and I don't actually like it as much, so I don't know if you can still get the old one. You know, let me get out of PowerPoint. E to delete, and this, yeah, I had some other. But, you know, you just choose your pen and you draw, you know, and you get a different color, whoops, like that. And you can erase and all this, different size. I really like it. So go back to red. Let me just move that up here. I don't know if I can. Don't want it in the way here. Okay, anyways. Okay, so here's what you do in this case. You've got your object and you've got your eye. So draw a solid line perpendicular to the mirror. That's very important. Don't just go across, you know, horizontally and then, you know, try to find your image back here. That's not how you do this. It's perpendicular to the mirror. Again, this is now 3 centimeters, let's say. Oh, that's too thick. And then you measure this one, and that would be 3 centimeters. Remember, the image is the exact same distance behind the mirror as the object is in front of the mirror. Solid lines in front, dotted behind, and no arrows. This one is just used to find the location of the image. Once you have that, you're going to start directing rays. So this would be 1, 2. Your third step is to use your ruler to draw a line to the bottom of the eye, let's say, and another one, say 4 to the top of the eye. But don't forget, behind the mirror, they're dotted. In front of the mirror, they're solid. Once again, it's the object that is giving off light, not the image. And so we've drawn these rays. Maybe I'll call this 5 and call that 6. We haven't drawn these yet, all right? The rays going into your eye are reflected off the mirror, okay, from the, as if they're coming from the image. So we put our arrowhead somewhere in the middle of that line going into the eye, not out of the eye. Then all we have to do is, let's say we take this one going into the top of the eye. We're going to take the point at which this dotted, then solid line intersects the mirror, and we're going to draw it back to the top of our, or right into the middle of our object. And these lines are a little bit off here. All right. Of course, the ray is really going this way. The light is coming out of this, hitting the mirror, and it's reflecting. This is a way of doing it without like measuring. If you knew the angle of incidence here, you could measure the angle of reflection and draw it, but this is an easier way of doing it. All right, so you do this one, and then you do the bottom one, where this line intersects the mirror, draw it back to the object, but put your ray going in the correct direction. So the light is coming off this object, hitting the mirror, and then going back into the eye. All right, so, you know, if you can do that, then we could give you, you know, a mirror here, and we could draw an eye up here, and you got your object, and you could do any one. Remember, if you did this, solid line to the mirror, dotted behind a certain amount, and then you would dot this, and then solid into the eye, and of course that's reflecting into the eye, and this is going to be a little bit harder to do. But solid in front, dotted behind, that's going there. And then you would take this line and you would, whoops, that's a solid line. You'd bring it back to the object, and this one back to the object. So as if the object's giving off light, bang, hitting, going into the eye, that kind of thing. It's a really messy drawing. Okay, so hopefully that helps you out. And let me see if I can show you what would essentially be coming up after this. So at this point, you should know the laws of reflection. The angle of incidence equals the angle of reflection. The normal, the incident and reflected ray lie in the same plane. You know the salt characteristics. And this really gets you, after that, let me see if I can close this, into curved mirrors. Let's see if I've got the other PowerPoint up. And so basically what I would have my class do anyhow, starting to look at concave mirrors. I mean, there's experiments, of course, with this as well. And just the concept that a curved mirror, you know, has a, you know, either a concave or a convex surface. If you're taking it from a basketball, you're going to have a concave surface on the inside. If this was the reflective side was on the inside. I'm using PowerPoint again to do that. And, you know, there's more complexities when it comes to these mirrors because there's various terminology, and this is probably going off the page, so that's not critical that you get all that. Okay, but I'll have my class write this as a note, and we'll draw the mirror, and then eventually you'll do experiments with curved mirrors, and it gets a little complicated, but just hang in there. All right. So hope that helps. See you again soon.